Hello everyone, welcome to this revision video on chapter 8 Forces in Motion of grade 8 physics. In this chapter we'll start to understand what is pressure. So pressure is defined for all solids, liquids as well as gases. So pressure in solids is defined like this. So pressure is the force exerted per unit area of the object. So if I take pressure, the formula is given by force exerted per area of contact. So in this diagram we have a cuboid which is placed in position 1. So here this is the area of contact. Now in the second picture the same cuboid is placed in a different manner, so the area of contact decreases. Now as the area decrease, the pressure will increase. So the unit of force is Newton and the unit of area is meter square. So the unit of pressure becomes Newton per meter square. Here we can take another example. Let's say you have a blunt pencil and a sharp pencil. If you poke yourself with a blunt pencil, you won't feel much pressure, whereas if you poke yourself with a sharp pencil, you will feel a lot of pressure, because as area decreases, as the area of contact decreases, as the area of contact decreases, the pressure increase. The pressure increase because they are inversely proportional to each other. Now, we'll take a look at the problem. So these problems are usually asked for 3 marks. Let's read the problem. A force of 100 Newton spreads over an area of 2 meter square. So we have to calculate what's the pressure. First, let's write down the given data. So we have been given with force. The value of force is 100 Newton and the value of area given to us is 2 meter square, and we have to calculate what is pressure. Now we'll start with writing down the formula for pressure. Pressure equals force per area. Now in the second step we have to substitute for force and area. So the value of force is 100 newtons and the value of pressure is 2 meter square. So pressure will be equal to 100 by 2 is 50, so 50 newtons per meter square. So this will be the answer to the question. Remember, 1 mark will be awarded for writing the formula, 1 mark will be awarded for substitution, and 1 mark will be awarded for the answer along with the correct units. Let's look at one more question. A hammer is used to push a nail into the wood. The area of the point at the end of the nail is 1.5 millimeter square. The pressure needed for nail to go into the wood is 50 Newton per millimeter square. We have to calculate what is the force needed for hammer. Again, we'll start with given data. So here we are given with the area of contact. Area is 1.5 millimeter square. Then we know the pressure. Pressure is 50 Newton per millimeter square. Okay. So here both the units have millimeter square in common. So we don't have to do any conversions. Okay. We have to keep that in mind. We have to calculate what is the force exerted. We'll go back to our traditional formula which says pressure equals force by area. Now we have to slightly modify this formula such that we get force on one side and pressure on the other. So we'll take this force and we'll keep it as it is. We'll take the pressure area on the other side. So the equation becomes force equals pressure times area. we know what is pressure. Pressure is 50 Newton per millimeter square times the area is 1.5 millimeter square. Here we can cancel off these units. So 50 into 1.5 is 75. So the value of force will be equal to 75 newtons. So this is the correct answer for this question. The next topic is pressure in liquid. So liquids will exert pressure due to the weight of the liquid. So let's assume a fish tank. Okay. Let's say we have a fish down here at the bottom and we have a fish somewhere near the middle. Okay. Now let's assume the entire fish tank is filled with water. Now due to gravity, all the water will try to go down, so it will be exerting some force on this fish. Now if we consider the force exerted by the water, let's say at point A, to the force exerted by water at point B, the force exerted by water at point A will be small compared to that of point B, because there's a lot of water which is present on the top of this fish. Let's say on the top of fish B we have a lot of water. Lot of water means there's a lot of weight. Remember, weight is equivalent to force. Okay. So when someone asks you what's your weight, you should not be telling something like 45 kg, right? Because weight is measured in terms of newtons. Okay. Weight is the effect of gravitational force on an object. So again, weight is measured in terms of Newton, but mass is measured in terms of kg. Okay, there's a common misconception between what is mass and what is weight. So weight is force experienced due to gravity, and mass is the amount of matter in a substance. Now if we consider these two fishes, because there's less water on top of this fish, right, there will be less weight compared to the amount of water which is present on the top of fish B. So the pressure will be larger at point B compared to point A. So we can conclude this with writing a point. Okay, I'll say liquid pressure increases with depth, which means as you go deeper in water, the pressure experienced by you will be larger, because there is more water on top of you which is exerting a lot of force due to gravity. Now we can see a simple demonstration on the right side of the screen. So here we have a water bottle. You can do this experiment at home. You can take a plastic water bottle, poke 3 holes and fill water into it. So when you fill water, after filling water you can close the cap and the water will not flow. Okay, we can make that observation. When the bottle cap is closed, the water will not flow out of the water bottle, but when it's opened, right, the water will start to flow, and there will be the largest projectile at the bottom compared to the projectile at the top, because the pressure will be larger at the bottom due to all the liquid molecules which are present on top of this point. So there will be a lot of water on top of it, so there will be a lot of weight on top of this point, so there will be larger pressure compared to this point, because there is less amount of water present on top of, let's say, point A, B and C, right? So pressure will be largest at point C compared to point A or point B. Next, liquid pressure is also dependent on density. Let's take an example of 2 aquariums. Let's say there are fishes in 2 aquariums. Now let's take the common depth, let's say at the bottom of the fish tank. Now in one aquarium I'll fill pure drinking water, okay, let's say, or distilled water. Okay. In the second aquarium I'll fill salt water. Now the force exerted by the distilled water will be less than the force exerted by the salt water, because salt water has more density. Salt water has more density, so it will exert more force on this fish compared to this fish. So let's say this is clean water or drinking water, not drinking water, let's call it distilled water instead of that. So as the density increases, the pressure exerted also increases. Okay, that's the point. Now gas pressure, gas pressure is due to the collision of gas molecules with the walls of the container. So gas pressure, it is due to collision of gas molecules, collision of gas molecules with the walls of the container, with the walls of the container. Okay. Now let's say you blow a balloon. So when you blow a balloon, there will be gas molecules which will be randomly moving inside the balloon, that will keep hitting the walls of the balloon, right? And this will exert force in this direction. Okay. Now we'll take a special case where we also heat this balloon. Okay. On heating the balloon, right, we are increasing the temperature of gas molecules, which means we are providing more heat energy to the gas molecules. Now when the gas molecules absorb all the heat energy, their kinetic energy increases, which means their speed increases. If their speed increases, the number of collisions with the wall also increase. So here the number of collisions with the wall increase because the speed of the gas molecule will be very large compared to a balloon which is not heated. Because of this, the balloon expands. You can also try to do this experiment. You can take an empty balloon, you can take a water bottle, right, fit a balloon on the top of this water bottle, right. Let's say you pour some hot water here and like put it in a water bath, okay, or you can don't have to use water here, you can leave it empty, right. Keep it in hot water, the balloon will start to inflate because all the heat energy is absorbed by the gas molecules which are there inside the water bottle, and they'll start to move randomly with larger speeds. So that will increase the pressure inside the balloon. So upon heating, right, the pressure, or to be more precise, I'll write it as the gas pressure, the gas pressure increases. Now, the next one is density. Density is defined as the mass per unit volume. Its formula is given by mass per volume. So the unit of mass is kilograms and the unit of volume is meter cube. So the density has a unit of kg per meter cube. Okay. So if we have two liquids with different density, the denser liquid will sink to the bottom and the less dense liquid will float on the top. So you can try this experiment with a mixture of castor oil and water, or with a mixture of cooking oil and water. You can use sunflower oil and take some water, mix them up and leave it for a while. So you'll start to see, like, if the oil has more density than water, then you'll start to see it getting deposited at the bottom of the bottle, and water will start to deposit on the top. Now here I have taken a wooden block. So when I completely immerse this wooden block inside the water tub, the volume increase. So initially the volume was 100 liters. When I completely immersed it, it became 105 liters. So this is how you can determine what's the volume of the given shape. Right. So here I have taken another block which is of aluminium. So both of them have the same volume. We can even prove it. So I can take out the wooden block out and I'll measure the volume of aluminium block. So the volume of aluminium block is 5 liters, whereas the mass of the wooden block is also 5 liters. Sorry, the volume of wooden block is 5 liters, but they have different mass. Right? Mass is 2 kg for wooden block and mass is 13.5 kg for an aluminium block. So the denser substance will go to the bottom, will sink to the bottom, and the less dense substance will float on the top. Okay. So density will be different for different materials. Okay. The next concept is moment of force. Moment is nothing but turning effect of force. Moment is turning effect of force. And the formula for moment is given by moment of force equals force times perpendicular distance. Force times perpendicular distance. Now we have a cat, and that cat, let's say there's a pivot here and there's a plank, and that cat is standing at some distance d away from the pivot. So it has a weight of F newtons. So here the moment will be given by just F into d. Now the unit of force is newtons, whereas the unit of distance is meters. So the unit of moment will be equal to Newton meter. Now we'll take the next topic. We'll solve some questions on moment. Let's read the question. A boy uses a force of 5 newtons to close a large door. The handle is 1.5 meters away from the hinge. What is the moment of force? So let's take a door. Now let's say there's a handle here which is 1.5 meters. This is 1.5 meters away from the hinge. The hinge of the door will be attached to the wall somewhere here. Okay. Now the boy exerts a force of 5 newtons. Let's say the boy is exerting a force in this direction. Now because there is a moment, there will be a turning effect. Right? The door turns because of the moment of force. But now we have to calculate what is that value. So first, before anything, it's always good to write down the given data. So let's write down what is the force exerted by the boy. So the force is 5 newtons. So the perpendicular distance. So perpendicular distance is 1.5 meter. So the moment of force will be equal to force times perpendicular distance. So here the force is 5 newtons and the perpendicular distance is 1.5 meter. So the moment of force will be equal to 5 times 1.5, which is 7.5 Newton meter. So this will be the moment of force. Let's take the next question. Sunita weighs 600 newtons and she sits 1.5 meter away from the pivot, and there's a small error in this. So instead of 600, let's change it to 400 newtons. Okay. So there's a small typo. So Sunita weighs 400 newtons. She sits 1.5 meters away from the pivot of a seesaw with her mother 1.1 meter away from the pivot on the other side. Her mother weighs 600 newton. Is the seesaw balanced? Now, so let's take a seesaw. Let's say we have two people. So let's say person A, who is Sunita. Sunita is sitting 1.5 meters away from the pivot. So the distance from her to the pivot is 1.5 meters, and she weighs 400 newtons. Okay. Now her mother sits 1 meter away. So her mother sits, let's say, 1 meter away, which is much closer to the pivot. The distance is 1 meter, and her mother weighs 600 newton. 600 newton is approximately 60 kg on earth. Remember, like, your weight can change, right? If you go to moon, your weight will be much less because there is less gravity. Your weight depends on gravity. If you are in space, right, if you are in space, like in outer space, and you're floating, you'll be weightless. Astronauts are weightless, but they are not massless, right? Because of the presence of matter, they'll be mass. Let's say I'm 60 kg on earth, I'll be 60 kg on moon. Whereas if I'm weighing 600 newtons on earth, I'll be weighing something different on moon. I'll be weighing much less. So now we have to calculate what is the moment. So Sunita is sitting 1.5 meter away. So there will be a turning effect in anti-clockwise direction. Then her mother is sitting 1 meter away. Because of this, there will be a turning effect in the clockwise direction. If the turning effect in the anti-clockwise direction is same as the turning effect in the clockwise direction, then the entire system will be balanced. So let's calculate what is the anti-clockwise moment. So before that, let's write down the data. So let's write down the given data. Right. So let's say weight of person 1, I'll call it F1, is equal to 400 newtons, right? D1 is the distance from the pivot. Let's say it is 1.5 meters. Now if you want to calculate the anti-clockwise moment will be equal to F1 times D1. I'll call it M1. So this is 400 times 1.5, which is 600 Newton meters. So this is the anti-clockwise moment. Let's write down the second set of data, which is for her mother. So let's say F2 is equal to 600 newtons and D2 is 1 meter, and clockwise moment, again this formula is still given by F2 into D2. Now this will be equal to 600 times 1, which is 600 Newton meters. So this is M2. So we can clearly see that M1 is equal to M2, right? So if the anti-clockwise moment is equal to the clockwise moment, then the moments are balanced and this will be in equilibrium. So the seesaw is balanced. So we can write the conclusion. The seesaw is balanced. The seesaw is balanced because the total anti-clockwise moment is equal to the total clockwise moment. Alright, that completes this problem. Okay, so that's it for our discussion with this chapter. If you have any doubts, you can post it in GC or you can send a mail to me. I'll try to clarify that as early as possible. Thank you.